Hello everyone. Let me start with a question. When you look around, a speeding car, the sound of music, light reflecting from your spectacles, or even the stars twinkling above, do you think all of these can be explained by the same simple laws? Physics is vast, and to study it systematically, scientists have divided it into different branches. Each branch focuses on a particular type of phenomenon, whether it is the motion of objects, the behavior of light, or the mysteries of atoms and galaxies. This division not only makes physics easier to understand but also shows us how deeply interconnected the natural world really is. Let's begin with mechanics, the oldest and most fundamental branch of physics. Mechanics studies objects at rest, that's statics, and objects in motion, that's dynamics. It explains key ideas like displacement, velocity, acceleration, and force. The cornerstone here is Newton's second law of motion, which says force equals mass into acceleration. Narrated as F equals m into A. Example, a 5 kg mass accelerating at 2 meters per second squared experiences a force of 10 newtons. Mechanics explains the motion of vehicles, projectiles, satellites, and even rockets leaving Earth's gravity. Now, let's move to waves, oscillations, and heat. Oscillations describe periodic motions, like the swing of a pendulum or the vibration of a guitar string. These oscillations lead to waves, the way sound travels through air or ripples form in water. Next comes heat and thermodynamics, which studies how heat, temperature, and energy are related. A key principle here is the first law of thermodynamics, which states heat supplied equals change in internal energy plus work done. Written as delta Q is equal to delta U plus delta W. Applications: from designing engines and refrigerators to understanding how our bodies maintain temperature, thermodynamics is everywhere. Another fascinating branch is the properties of matter. This includes elasticity, viscosity, and pressure in fluids. For example, Pascal's law tells us that pressure applied on a confined fluid is transmitted equally in all directions. That's how hydraulic lifts race cars so effortlessly in service stations. Now comes electrodynamics, the study of moving charges and electric currents. One of its simplest laws is Ohm's law, voltage equals current into resistance. Narrated as V equals I into R, electrodynamics explains how circuits, motors, and generators work, the very backbone of our electrical world. Next, we explore the world of optics, atomic physics, and nuclear physics. Optics deals with light, reflection in mirrors, refraction in lenses, and even advanced concepts like interference and diffraction. That's why spectacles, cameras, and telescopes all rely on optics. Atomic physics zooms into atoms, explaining electron orbits and spectra. This gave us quantum mechanics and laser technology. Nuclear physics explores the heart of the nucleus. Nuclear fission and fusion release enormous energy. Fusion, in fact, powers the sun itself. Applications range from nuclear reactors producing electricity to medical imaging techniques like PET scans. Modern physics extends into electronics, astrophysics, and computer science. Electronics and communication focus on semiconductors, transistors, and circuits. Think about your smartphone, TV, or internet, all thanks to electronics. Astrophysics explores the universe at the grandest scale, stars, galaxies, black holes, and the origin of the cosmos. The Hubble telescope, for example, gave us breathtaking images of galaxies billions of light years away. And then comes computer science, which combines physics with computation to simulate weather, design aircraft, and even develop artificial intelligence. From the tiniest microchip to the largest galaxy, these branches of physics continue to shape our world and future. So, let's quickly revise what we've learned. Physics is divided into branches to make its study systematic. Classical branches include mechanics, waves, thermodynamics, properties of matter, and electrodynamics. Advanced branches include optics, atomic physics, nuclear physics, electronics, astrophysics, and computer science. Each branch seems unique, but together they form one unified science, physics, that explains the behavior of everything from atoms to galaxies. I hope you now see physics not as isolated topics, but as an interconnected web of knowledge that explains our daily lives, technologies, and even the stars above. See you in the next session with another fascinating concept of physics.